Students, this is the review video for Unit 6 test on Wednesday of this week. There are four major topics on the test. The first one is direct variation, and I'll come back and give you some notes on that in just a second. The second one is the parent function. The third one is parallel and perpendicular lines. And the fourth one is standard form. Make sure you take your notes on your own paper for this and bring it to class. You'll be able to use this on your test, and we'll give you bonus points for having done this video. So it'll help you out in a bunch of different ways. Alright, let's start with direct variation. Okay. First, with direct variation, we talked about the equation. Okay. The standard form equation for direct variation is y equals kx, where k is not 0, so k is some number. So some examples of this are y equals 3x, y equals 1/2 x, y equals negative 2/3 x. So basically anything that has y equals some number and then an x after it. Okay? Remember that this is close to y equals mx plus b, but we're missing the b. b equals 0, so you just end up with the y equals mx part, which we call y equals kx. Okay? The graph of this, because it has a b of 0, goes through the origin. Okay, so it must pass through 0, 0. And the second part is the graph must be one straight line. So here's some examples of a direct variation. This is a direct variation because it's a straight line and goes through the origin. This is one that's just in the first quadrant. And this is one that goes downhill. Okay. The only rule is straight line through the origin, so it must pass through 0, 0. Okay. Problems with direct variation are done as proportions, and you guys had a lot of practice with this back in middle school. This is also the butterfly problems that you did back then that we've talked in class. Here's an example. Bob makes $22 for mowing 2 lawns. How many lawns would he need to mow to make 100? No, let's do 200. $200. Okay? So what we do is we're going to set up a proportion. Okay? He makes $22 for 2 lawns. So this is dollars and this is lawns. And we don't know the number of lawns, but we know he wants to make $200. Okay? So when you get it set up like that, you're going to cross multiply. So this would be 22 times x is 22x equals 2 times 200 is 400. Then when it's beside it, we're going to divide it. So 22 on each side. Divide out there. X equals. Let me take my calculator here and divide 400 by 22. 4 divided by 22 is 18.2. So we always come across this question when we're dealing with money: would 18 lawns be enough, or would he need to round up to 19? And when you're dealing with money, you always have to round up, because if you just did 18 lawns, 18 times $11 per lawn would mean he would only have $198, and so he would be a little bit short. So we would need to go up to 19 lawns to be able to get to $200. 19 lawns would be $209, so he would have plenty of money. The next thing that we want to talk about is the parent function. Okay, the parent function is what all lines started out being. It's like your parents. It's the mother and the father function, y equals x. If we graph this on our graphing calculator, this is the perfect straight line that goes from corner to corner through the origin. Okay, it has a slope of 1 and a y-intercept of 0. It's called y equals x. Okay, slope of 1 means it goes up 1 over 1, so up 1 over 1, up 1 over 1, up 1 over 1. Y-intercept of 0 means it crosses through there. Okay. The types of problems you'll see things like if you were to double the slope, what would happen? So if we were to double the slope, well, the slope in the parent function is 1x, so if we were to double that, it would change to 2x. So that would affect the line this way. Instead of going up 1 over 1, we'd have to go up 2 over 1, up 2 over 1. And so you get a much steeper graph because of this line right here. Okay? Kind of the opposite of that, if you were to take and do half the slope, if you change it to a fraction, y equals 1/2 x, then instead of going up 1 over 1, you're going to go over 2, up 1 over 2, and you can see that you get a much flatter graph. So the fraction makes it flatter. Okay? If we ever put a negative in front of the parent function, all that does to it is make it go downhill. The negative just makes it go downhill. Okay? If we add something to the end of it, if we change the y-intercept, right now the parent function has a y-intercept of 0. But if we change that y-intercept to a number like 2, then this is what it does to it. Instead of going through the origin, it starts 2 units up and then goes up 1 over 1, up 1 over 1. And so it looks like this. So this causes it to shift up 2. It shifted up 2 units. Okay. Likewise, if we do a subtraction from there, this is going to shift down 3. If you ever forget these things on your test, you can always go to y equals on your calculator, type in y equals x, and hit graph, and then go to y2 and type in x minus 3 and hit graph, and it'll show you both pictures on there. It'll show you this one that goes through at the origin, and it'll show you the one that's been shifted down 3. So you'll be able to make that. We learned how to make these predictions in class, but you'd be able to actually see it on your graphing calculator if you did it. Alright, the next thing we're going to talk about is parallel and perpendicular. And you learned back in middle school and elementary what these lines looked like. Parallel were just lines that don't touch, and perpendicular were lines that cross, but they cross to make 90-degree angles, so they crossed in a special way. In class, what we learned about was their slopes, and parallel lines have equal slopes. So y equals 2x plus 1 and y equals 2x minus 6. These would be parallel because they both have a slope of 2. And if you could even type those in the calculator and you would see that they would be parallel to each other. Perpendicular, we learned to have negative reciprocals. And remember we referred to that as flipping opposites. And what that meant is if you had a slope of 2/3, the 2 had to go to the bottom, the 3 had to go to the top, and if the first one was positive, then this one had to be negative. So 2/3 and negative 3/2 are flipping opposites. So these guys would be perpendicular to each other. Y equals 1/2 x plus 2. Well, the flipping opposite of 1/2 would mean the 2 would go to the top, the 1 would go to the bottom. It would have to become negative because that one was positive. So this would be y equals 1/2 x plus 2, and this could be y equals negative 2x plus 1. Okay? We typically wouldn't write this 1 underneath there, so we can go ahead and get rid of that. It would just go to negative 2x plus 1. These would be perpendicular to each other. Now the way the STAR test and our test is going to complicate it is they're going to give you one of them will be like y equals 3x plus 3, and the other one will be in a standard form. And you'd have to solve this second one for y so you could compare the slopes of each one. So be ready for that tomorrow as well. Alright, to close out this review lesson, we're going to talk about standard form, and this is what we just did yesterday in class. Standard form is in the form ax plus by equals c, where a, b, and c are integers, which means they were whole numbers, and that they could be positives or negatives, and that a is positive. Okay? So some examples of standard form would be 4x plus 2y equals 6, 3x minus y equals 9, 5x plus 4y equals 10. So in all cases, these numbers are integers, and this one is always positive. Okay? Example of how to put one into standard form. If I have y equals 1/2 x minus 2, we first told you to get rid of fractions by multiplying by the denominator. So our denominator is 2, so we're going to multiply everything in here by 2. So it gets a triple rainbow. 2 times y is 2y equals 2 times 1/2. You could type that in your calculator, or you could just do half of 2. That is 1x, and then 2 times a negative 2 is negative 4. The next thing we wanted to do was get the x and y on the left-hand side. So this guy needs to be moved all the way over here. And we talked about when we move something across the equal sign, it changes sign. So when we move him over here, he's going to become a negative 1x. So this will be negative 1x. That's a positive 2y, and that's still a negative 4. Okay. Now this is not in standard form because this front guy is negative. And so we told you that the way to get rid of a negative was to multiply everything in there by negative 1. And this will change the sign, and you got to do it to everybody in here. So then this will be a triple rainbow. So negative 1 times positive 1 will be 1x. Negative 1 times a positive 2 will be negative 2y. And negative 1 times negative 4 will be positive 4. So this would be standard form. From that, we showed you guys how to find the x and y intercepts. And so I'll go ahead and review that right here as well. Hey, we used a technique called the cover technique, and what you did was you covered up. If I want to find the x-intercept, then all I would do is take something and cover up the y. I'm going to erase it. If I cover up that y and write what's left over, I have 1x equals 4, and that is the x-intercept. X equals 4, so we would write that as 4, 0. Okay, so if you want to find the x, so to find the x, you cover the y. Okay, now if I want to find the y-intercept, I'm going to take my eraser, and what I would do is I would erase the x, okay, or cover x, and then I write what's left here, which is negative 2y equals 4. And then I just solve that. So divide both sides by negative 2, and I get y equals negative 2. So this is my y-intercept, which is written as 0, negative 2. Okay. Hopefully this will help you on your test. Be ready tomorrow.